Well, hello and welcome to GetChemistryHelp.com. My name is Dr. Kent, and in this video we're going to work practice problems using all of the things we've learned about mole calculations. We're going to work problems that involve molar mass, Avogadro's number, and the mole ratio that's obtained from chemical formulas. So as we'll see, we have several different scenarios here, and there's not really a set formula per se, but given the data and given what it's asking, we can determine which of our tools we need to use. So let's just go ahead and jump in here with the first one. So this one says, how many atoms are in 8.21 grams of lithium? So I know I'm starting with 8.21 grams of lithium. Now, whenever you have mass, the only thing you can ever do with mass is use the molar mass and turn it into moles. So I'm going to find the molar mass of lithium. It's right here. So that says that there's 6.94 grams per mole of lithium. Well, I need grams to cancel, so I'll put the grams on the bottom. 6.94 grams per mole of lithium. So now I'm in moles of lithium, but I want atoms. Well, whenever we go from moles to atoms, atoms are a kind of particles. That's where we use Avogadro's number. So I want moles to cancel, so mole will go on the bottom. 1 mole lithium down here is Avogadro's number of lithium particles. And what's the smallest piece of lithium called? Oh, it would be an atom. So atoms. So moles lithium cancels. So 8.21 has 3 significant figures. 6.94 has 3. 6.022 has 4. So my answer should have 3. And I got 7.12 times 10 to the 23rd atoms, or atoms of lithium. Okay, how about number 2? What is the mass in grams? So I want to find mass in grams of 4.17 times 10 to the 21st formula units of magnesium perchlorate. Okay, so I'm starting with 4.17 times 10 to the 21 formula units. There's not a great abbreviation, so I'll just put form units, I guess. Magnesium perchlorate. So magnesium is 2 positive. Perchlorate would be 1 negative, so it must be Mg parenthesis ClO4 parenthesis 2. Okay, well, I've got formula units. Again, those are a kind of individual particles of a substance. So whenever you have particles, we got to use Avogadro's number. Well, now the particles has to go on the bottom, so Avogadro's number would go down here. And of course, that's always equal to a mole of whatever it is we're looking at. So in this case, it's a mole of magnesium perchlorate. Okay, so now formula units have canceled. Now I've got mole, but I want mass. So how do we go from moles to mass? Well, moles to mass, it's right in the name. We use molar mass. So to find the molar mass of magnesium perchlorate, we have to add up the magnesium, the chlorines, and the oxygens that are present. So we have 1 magnesium in our formula. We have 2 chlorines. And we have 2 times 4, 8 oxygens. So let's find magnesium. Oh, it's right here. So 24.31. We have 2 chlorines. That's 35.45. So 2 times 35.45. And 8 times oxygen. Oxygen's right here. 16.00. 16.00. So let's find the total mass, or the molar mass, of magnesium perchlorate. This would be 128.00. So we add these all together, and I got 223.21. And of course, the molar mass, that's the mass of a mole. So I have the mass over mole. I want moles to cancel, so that's perfect. So 223.21 grams per mole of magnesium perchlorate. So moles will cancel. We have three significant figures here. We have 4 for Avogadro's number. We have 5 for the molar mass, so 3 is the fewest. So multiply through, and I got 1.55 grams. How about number 3? This one says, how many sulfur atoms, again, that's a kind of particle, so I know I'm going to have to use Avogadro's number at some point, are in 72 grams. That's a mass, so I'm going to have to use molar mass at some point, of cobalt-3 sulfate. Okay, well, let's start with the one we're given. That would be 72 grams of cobalt-3 sulfate. So cobalt-3 would have a 3 positive charge. Sulfate has a 2 negative. Let's just write that over here. Cobalt-3 positive. Sulfate is 2 negative. So remember, we can do our crossover. Put a 2 here, put a 3 here, and I would get cobalt 2 parenthesis SO4 parenthesis 3. Okay, well, I'm in mass of cobalt-3 sulfate. Well, the only thing you can do with mass is molar mass. So I need to find the molar mass of 2 cobalts, 3 sulfurs, and 12 oxygens. So let's do that. 2 cobalts, 3 sulfurs, and 3 times 4, 12 oxygens. So cobalt is over here. It's got a mass of 58.93. 3 sulfurs, they have a mass of 32.07. And 12 oxygen, they have a mass of 16.00. So let's multiply this out. So this gives me 117.86. This one gives me 96.21. And this gives me 192.00. So I add them all together. The total molar mass is 406.07. And again, that's the mass of a mole of cobalt-3 sulfate. Well, I have grams. I need grams to be on the bottom. So I'll flip this and put 406.07 grams on the bottom per mole of cobalt-3 sulfate. Grams cancels. I'm left with moles. But notice I don't want particles of cobalt-3 sulfate. I want sulfur. So I have 2 different substances. One is sulfur, one is cobalt-3 sulfate. So remember from our lesson on mole ratio from chemical formulas, we learned this is where we use the formula to determine the ratio. So how many sulfurs are there in every mole of cobalt-3 sulfate? Well, we just saw there were 3 of them. So for every 1 mole of cobalt-3 sulfate, that'll have to go on the bottom for it to cancel. There are 3 moles of sulfur in it. Okay, now I have moles of sulfur. I want atoms, particles of sulfur. So to go from moles to particles, that's where we use Avogadro's number. So 1 mole of sulfur on the bottom. Avogadro's number of sulfur particles, or atoms, on the top. So moles cancels. Let's look here at our significant figures. 72, that's 2. This molar mass has 5. Now this, remember, is exact because there's exactly 3 sulfurs in cobalt-3 sulfate. It's not measured or approximate. So this is exact. Avogadro's number is 4. So we have 2, 5, exact, and 4. So the fewest would be 2. So I worked that out and I got 3.2 times 10 to the 23rd atoms. So that's how many atoms of sulfur are in 72 grams of cobalt-3 sulfate. Number 4, how many grams of lithium are in 30.6 grams of lithium nitride? Okay, so I've already noticed a couple of things. I have grams, which means I'm going to have to use molar mass. I have grams here. I'm going to have to use molar mass. I've got lithium and lithium nitride. Those are 2 different substances, so I'm going to have to use the mole ratio to relate them. So let's start with what I have. 30.6 grams lithium nitride. Okay, lithium lives over here. So it's in group 1. It's 1 positive. How about nitride? Ide, remember, tells me it was just a non-metal by itself. So it comes from just nitrogen. Nitrogen's 3 away, so it must be 3 negative. So the formula would be Li3N. Well, I have mass of lithium nitride. Anytime you have mass in these types of calculations, you have to use the molar mass. So we've got to add up 3 lithiums and 1 nitrogen. So 3 lithiums, 1 nitrogen. So the mass of lithium was right here, 6.94. So 3 times 6.94. 1 nitrogen, 14.01. So 1 times 14.01. So we had 20.82 is the total mass of lithium. 14.01 is the total mass of nitrogen. Add those together, and I get 34.83 grams per mole of lithium nitride. Again, I want grams to cancel, so I'm going to flip that and put the grams on the bottom. Per mole of lithium nitride. So grams are gone. Now I'm in moles of lithium nitride. So once we're in moles, that's when we can do the mole to mole ratio and relate 2 different substances. So how much lithium is in lithium nitride? Well, for every 1 mole of Li3N, there's 3 moles of lithium. So I have to put the moles of lithium nitride on the bottom. So 1 mole Li3N on the bottom, and there's 3 moles of lithium in it. Okay, now I'm in moles of lithium, and what do I want? I want grams. Okay, whenever you go from moles to mass, we got to use molar mass. So for the moles of lithium, I find the molar mass of lithium. Again, it's 6.94. So 6.94 grams is the mass of a mole of lithium. So how about significant digits? We have 3 here. We have 4 in the molar mass. This mole ratio is exact. I have 3 in this molar mass. So 3 is the fewest. So I get 18.3 grams. So that's the mass of lithium and 30.6 grams of lithium nitride. Now our next question says a sample of cadmium borate contains 72.9 grams of boron. What mass of cadmium will the sample contain? Okay, so there are a few clues that I can pull out in terms of what kind of techniques I might have to use. Well, 72.9 grams of boron, that means I'm going to have to use molar mass of boron at some point. I want mass of cadmium, so I'm going to have to use molar mass of cadmium at some point. But I'm trying to turn boron, which is one substance, into cadmium, which is another. So 2 different substances, I know I'm also going to have to use that mole to mole ratio. So let's start with what we know, 72.9 grams of boron. Well, mass of boron, only thing you can do is molar mass of boron. So let's find it right over here, 10.81. So there's 10.81 grams in a mole of boron. Now I'm in moles of boron, but I need to relate boron here to cadmium. Well, how do I do that? Where's my formula? Oh, it tells me that cadmium and boron are both in cadmium borate. So what would cadmium borate be? Well, cadmium, it lives right here, so it's on our magic triangle. So remember, these 2 elements are always 2 positive. Borate is a polyatomic. It's BO3, 3 negative. So I can do my little crossover rule. So the formula must be CD3 parenthesis BO3 parenthesis 2. Okay, so what's the ratio of boron to cadmium? Well, there are 2 borons, it looks like, for every 3 cadmiums. So which one needs to go on the bottom? Well, I'm starting with boron, so I need to put 2 moles boron down here. for every 3 moles cadmium would go on the top. So now I'm in moles of cadmium, but I want mass of cadmium. So moles to mass, we use the molar mass. So here's cadmium. We see its molar mass is 112.41. So 112.41 grams is the mass of a mole of cadmium. So this has 3 significant figures. The molar mass of boron has 4. Mole ratio is always exact. Molar mass of cadmium has 5, so the answer would have to have 3, which is the fewest. So I get 1.14 times 10 to the third grams. Now you might have wanted to write this 1,140, which technically is 3 significant figures, but you might recall that we said these placeholder zeros are a little bit ambiguous. So it's better, if possible, just to write it in a clearer fashion that just gets rid of placeholder zeros. And that's the beautiful thing about scientific notation. It just clearly shows the 3 significant figures and eliminates any kind of ambiguity. Now, one other thing to note, when you're punching this in your calculator, remember, you want to multiply by anything that is on the top, and you want to divide by anything that is on the bottom. So when you're putting this in your calculator, you're going to enter 72.9 times 3 times 112.41 divided by 10.81 divided by 2. Or you can just work left to right and say 72.9 divided by 10.81, because it's on bottom, times 3, it's on top, divided by 2, because it's on bottom, times 112.41. And you should get this for your answer. Okay, our last one. What is the mass of sulfur in grams in a sample of manganese 6 sulfate containing 8.291 times 10 to the 24th oxygen atoms? Okay, so I see a few different things. Oxygen atoms, those are particles, so I'm going to need Avogadro's number. I want to go to mass of sulfur. So mass, I'm going to have to use molar mass. And I also see I'm going from oxygen to sulfur, 2 different substances, so I'm going to need a mole ratio at some point. So let's just start with what we're given, 8.291 times 10 to the 24th atoms. What kind of atoms? Oh, they're oxygen atoms. Okay, so I can turn oxygen particles into oxygen moles with Avogadro's number. So Avogadro's number on the bottom. That's the number of particles in a mole of oxygen. Now I'm in a mole of oxygen, but I want to go to sulfur. So how do I relate oxygen to sulfur? Well, we always do it through a formula. And in this case, the sample was manganese 6 sulfate. So manganese 6, that means Mn6 positive. Sulfate, we learned, is SO4 2 negative. So I can do my crossover if I want, like so. And that would give me Mn2 parenthesis SO4 parenthesis 6. Aha, but look, 2 to 6 is not the lowest whole number ratio, is it? The simpler way to write that would just be 1 to 3. So Mn parenthesis SO4 parenthesis 3. Because if I had 3 sulfates, well, 3 times 2 negative would be 6 negative. That will balance out 1 manganese 6 positive. Okay, well, I want to relate oxygen to sulfur. So how many oxygens are in manganese 6 sulfate? Well, 3 times 4. So there's 12 oxygens. How many sulfurs? Oh, 3 times 1, 3 sulfurs. So I want to get rid of oxygen. So I put oxygen on the bottom. So 12 moles of oxygen for every 3 moles of sulfur. So moles of oxygen cancels. Now I'm in moles of sulfur, but I want mass of sulfur. So how do we go from moles to mass? Well, by now we know we always use the molar mass. So just find the molar mass of sulfur. I need grams on top, so moles will cancel on bottom. So 32.07 grams is a mole of sulfur. Okay, how about significant digits? 8.291, that has 4. 6.022, that has 4. 3 and 12, those are both exact. 32.07 that has 4. So our fewest is 4. So I got 110.3 grams. So that is the mass of sulfur. Well, that wraps up our video on mole calculation practice problems. Leave me some feedback in the comments section down below to let me know what you think of this video, and we'll see you next time back here at getchemistryhelp.com. Thank you.